Hi, in the previous session, we have discussed about the principal stresses and strain with respect to Mohr diagram, how we are going to draw the strain stresses on this Mohr diagram. And in the Mohr diagram can be drawn with respect to three parameters. First is stress, second is strain, and third is moment of inertia. Might be some in IES question they used to ask such thing. They what in how many parameter we can draw with respect to we can draw the Mohr circle. So it is basically answer is three. And the remaining portion of this chapter we are going to cover in this lecture. So it will be quick lecture, but in this lecture, the first condition we are going to discuss about the pure stresses. So pure stresses is nothing but the there will be no elongation stresses. Tensile stress is not going to perform. Only the shear stress is going to perform on the element. You can see on the left top of this PDF, which shows that when you apply the forces, compressive forces at particular and the perpendicular direction, so it will purely when you apply a torque to the any cross section. So what will happen? It produces a pure shear stresses, and due to the pure shear stresses at 40 degree from the principal plane, it generated the tensile forces, and in the opposite diagonal of this element, it generated the compressive stresses, and it is exactly at 45 degree from the principal plane. So due to that, when you try to calculate for the maximum and minimum principal stresses, so it will turn out to be positive plus minus shear stresses. So this is the notation when you when the this kind of word come in the picture, that is the force is applied in the form of pure shear stresses. It's nothing but what the stress quantity, shear stress quantity is given. You have to take that quantity as a plus minus to their principal stresses with respect to major and minor principal stresses, and it always act on the element at 45 degree. But if you want to draw this on the Mohr circle, it will be on 90 degrees Celsius. And if they apply stresses, that is nothing but the nature of rho x and rho y, which is in the which has equal magnitude, and both are have like in nature, like both are acting the same direction. That is mean the the principal stresses which shows the positive nature, that and magnitude will be the same. Only thing is the nature is different. That shows that rho 1 and rho 2 value will be same, and in that condition, if you want to find out the maximum shear stresses, which is rho 1 minus rho 2, so it will become 0. So in condition principal stress is equal, and like that condition shear stress will be 0. And when the principal stresses is equal, that is mean the magnitude will be equal, and both are unlike. So, like stresses, so more mm, in which rho 1 minus plus rho 1, so which will shows that divided by 2, and which will give the value of rho. And this is the most uh, important statement, which is nothing but normal stresses on maximum shear stress plane. So most of time they used to ask this kind of question. So find out the normal shear stress on maximum shear stress plane. Maximum shear stress plane, uh, which shows, as previously we have seen, that maximum shear stress which were produced on element at 45 degrees Celsius. But we know if you draw this 45 degree on the Mohr circle, it will become 90 degree. So 90 degree where your stresses is the average shear stresses. And if you ask the maximum normal shear stresses on the maximum shear plane, so that is nothing but your average shear stresses, which will be calculate that C rho 1 plus rho 2 divided by 2. Now we are going moving toward the hydrostatic condition in which they used to ask, this is a simple one kind of question, so in which they used to ask to find out the mohr circle, or draw the mohr circle, or how will we represent the mohr circle if any body placed under the hydrostatic pressure. So in hydrostatic condition, you all know that when you put any body inside that, any object on inside that water, so what will happen? It will be, it will be in the compressive nature, and it is equal from the all directions on that body. So due to that, the magnitude will become zero, and due to that, shear stress will become zero. And in this condition, shear stress becomes zero, but stress will be in the negative nature, both in the condition. So that's why the value of principal and major principal and minor principal become same, and it will hold the negative sign, as well as you can see it has a zero radius. That means it has an infinite number of plane. If you want to find out the radius is zero, and plane in all direction. So because point has a infinite number of plane, infinite number of line you can draw through this point. So this is how we this apart from that, they will know, not going to ask anything. And now we move to the stress trajectory, which stress has the two kind of nature. One is positive nature and negative nature. Positive nothing but tensile in nature, and negative is nothing but compressive in nature. So when here I have taken example for the simply supported beam, which hold at the both end. And so when you put that simply supported beam like this, so what will happen, due to the concave shape, it will try to sag at the center of this rod. So due to that, the tension which is produced at the bottom layer, and the compressive nature which is produced as the top layer. So due to that, the entire section, completely entire section, which is divided into two parts. One is the compressive nature part, and the second is the tensile nature part at the bottom. And the this two section which is divided by a neutral plane. So it has its own trajectory, because it's like it's a kind of width up to which the compressive nature will be there, and after that it will be the tensile in nature will be there. So this trajectory has their own property. When they are cross each other, they will cross at 90 degree. When the straight line is crossed that neutral plane, which is not in compressive as well as tensile in nature. So if this any of this trajectory is going to cut that neutral line, so that is nothing but it show it will be cross at 45 degree. And with respect to each other, they used to cross at with respect to is nothing but that compressive and the tensile trajectory. If they cross each other, they will cross at 90 degree, which is nothing but perpendicular to each other. And another word is also called as orthogonal to each other. And now we move to the relation, and trust me, this relation is very very important, because it's relation between the stress and strain. So if you know any one quantity, which is nothing but if you know the stress, you can find out the strain, and if you know the strain, you can find out the stress. And in this stress and strain is nothing but the principal stress and strain. So if you from the stress, we are going to find out the from the strain we are going to find out the stress value. So here the formula is the modulus of elasticity divided by 1 minus mu square, that principal strain plus minor principal strain, which is multiplied by mu. This is how we can draw the first relation, and similarly the second relation will be similar to the first relation. Only thing is, when you take for the first major principal plane, there will be a multiplication of a Poisson ratio to the minor principal strain. And if you take for the second minor principal stress, in that condition, the mu value will be multiplied to the minor. This is e2. This is another. It's like major in opposite nature. If it is major minor principal stress, then the mu value will be applied to the major principal strain. So this is how these two relation are is drawn out of this two relation, and this relation is quite very helpful to find out the relation, and a simple kind of question might come on this two derivation, these two form. And another form is when two cross section which is at cut at 45 degrees, say 45 degree, and if they join together by glue. So in this condition, if you apply the tensile forces on that cross section, so what will happen due to that, if you apply the normal stresses, so due to the shear stresses which is produced at the cross section, due to that the normal stress when you apply it will produce two the kind of stresses in that cross section where it is cut at 45 degree. So it will be distributed into two section. One is the normal stresses, and the second is the shear stresses along that plane, cut plane. So the we are assume that the cross section is a dash, and you can get this a dash, and the angle at which it cut to the horizontal is beta, and p is the force applied, rho is the force which is perpendicular in the perpendicular to that cross section, and normal to the that cut cross section is rho n, which is nothing but strain at normal direction. So when you apply forces, in which if you if you distribute these forces, to take as a rho is distributed to, and it has an angle beta with respect to shear stresses. So in this condition, shear stress will become rho of sine beta, and in normal direction it will be rho cos theta. So this is how you can draw these two relation, which shows the normal theta is equal to rho into sine square theta, which is multiplied by area, and just because of these two formula, it will become this equation, and tau is equal to rho of sine beta into cos beta, and these are the two relation they used to give answer at some places. And also we have seen that in while discussing about this stress and strain, in which we have find out the equation for the principal plane angle, and the principal shear stress angle. So we have seen that the principal shear is the basic angle where if you are able to find out any one of it, which in which we have find out for the principal plane angle, and from that 90 degree we have a minor principal plane angle, and if you take a 45 degree from the major principal plane, you will get the maximum shear plane. So this is how you can draw on this diagram, so you can easily get. And with respect to that, now we move to the strain gauge, where the value we need to find out with respect to different strain gauge. So for the number of gauges by biaxial, if condition is given, the number of strain gauges required is equal to 3. And in this condition, strain roast, or, which is given, it's 3. And in this condition, you have to find out the strain produced in this particular direction. Now, it is divided in the three form, which is nothing but it's one kind of arrangement. So in the alpha arrangement, we used to call it as a rectangular arrangement. If alpha, that angle is at 60 degree, we call delta strain gauge form. And if the alpha is 120 degrees, then we used to call it as a strain. So this is how it can be reduced, and this equation is reduced from the this above equation. We have also seen this equation for the normal strain, and from that equation, if you want to find out for the 45 degree, as you seen that x and y direction, in which the strain gauge A and C is placed, and at 45 degree we have placed the B strain. Now when we apply the forces at this angle at particular zero direction, when you go for the finding the 45 degrees celsius, it should be at least minimum three strains. So the first strain we place at 0 degree celsius, with respect to that second is 45 degree, and third is 90 degree, which is 0 to 45. When you calculate the 45, the center gauge will be 45, and after that it will be multiplied by 2. So always start with zero, second will be the given value, and third will be the multiplication of the second value. So if you put the theta value in the first equation, so it will, what will do, in sine 0 value will be 0, and the cos value will be 1. So in this condition, the value of 1, which is the remaining portion will become this normal stress, normal, which shows that strain in the b direction, and strain x plus strain y divided by 2 plus strain x minus strain y divided by 2. This portion will remain, and after that, if you separate these two equation, so in which the strain of y direction from the both the equation get which is subtract from each other. So the remaining portion will be strain in x direction divided by 2 plus strain in y direction, strain in x direction divided by 2. The half of strain will become strain in x direction. So it will become strain at angle x. Uh, it will become strain equal to a direction, which shows that when we strain in x direction shows the stay which we have taken as a strain gauge. And if you want to find out for the y direction, in which the angle will become 90 degree. So in 90 degree, if you put the angle 90 degree, in which the multiplication of 2 theta 1 become minus 1, cos 180 is equal to minus 1, and sin 180 will become 0. So in this condition, if you put the value this formula, what will in this condition, the right hand side of this equation will become the strain in y direction, and strain in y direction which shows the strain gauge of C. So we have put the strain gauge of C, and another direction where we are going to find out for the 45 degree, in which if you take the strain in the normal direction, which shows the strain gauge in the b direction, and if you put the theta value as angle 45, so sine 90 will become 1, and cos 90 will become 0. So second term will become 0, and it will remain the third term and first term. So the 2 divided by 2, which is multiply to the left hand side, so it will become twice of the strain at strain gauge B equal to, and uh, when you given the value, and if you shift this value to the left side of this equation, it will become minus strain gauge at A, and minus strain gauge at C. So this how you will get to shear strain at that 45 degrees celsius. And same manner, if you find out the value of alpha at 60 degree, in which the notation is only given that the x direction, uh, it is A, at b direction when it plays at, it will be 60 degree with respect to this plane, and after that if you multiply with the 2 value by 2, which will become 120 degree from the initial plane. So in this condition, if you put this value in the previous equation, the same equation you will get in the second condition as well as in the third condition. If you find out for the third condition, you will get in different kind of option. But most of time they used to give the first condition, and if you remember this formula, it will be very helpful to understood. And if you remember these two condition, it will be good enough. No need to remember the third condition, because third condition you can find out, but these two condition you can remember. And they were not never used to ask above 60 degrees Celsius. They always used to ask at 45 degrees Celsius. So this is how we end with the second chapter, and in the upcoming section we will focus on the different topic of this this subject. So, bye.